concepts in digital logic are all going to be real important. So here we have a multiplexer, and we'll have a 4-to-1 multiplexer. And I'll have some stuff coming into it. I'll have A, B, C. I'll have how about the NAND? I don't think I can do an AND gate. I'll have the NAND of A and B going into 0, 0. I'll have just a 1 going into 1, 1. I'll have the NOT of C ORed with B going into 0, 1, and I will just have C going into 1, 0, and then my output is, I want my output to be F. Okay, oh, but you know what? I bet I had made a different circuit on the worksheet to do. But did I?
Number 2 is kind of like it. That's like the first one.
Okay, well this one's better because it has more stuff in it. Okay, so we need to write a Verilog module to go along with this. So usually the way to do a multiplexer is with an always block and a case statement. So you'll see how that works. So I'm going to type this up here. So module Verilog example. And my variables are A, B, C, K1, K2, and F, and my inputs can y'all see that? Yeah, y'all can read that. I wonder if it'll be legible on the video. Probably not. I probably need to make it bigger. And by the way, what we're doing right now is going to be something you'll be doing. You'll be using this in the lab for the rest of the semester. This kind of structure. Okay, so our inputs are A, B, C, D, K1, K2, and our outputs are just F. Okay, so now what we're going to do next is an always block. And the way an always block works is that you're going to have something called a sensitivity list. And whenever something in the sensitivity list changes, then everything, it'll run the code in the always block. But it's not always happening like it would with just a continuous assign statement. So if I just said right now assign F equal to something, that would always be running. But an always block only runs when there's a change in something. And so I'm going to use that here, although I don't necessarily have to for the multiplexer. When you start dealing with sequential circuits and flip-flops, you definitely want that because it's tied to the clock, and you don't want it to be changing all the time. You only want it to be changing on the clock cycle. So we're just going to practice that here. And so we'll have an always block, and we'll have always, and you have at, and then you have when you want it to change. Now, I don't have this shown that it's like synchronize with the clock or anything like that. And so I'm going to want it to change whenever A, B, C, or K1 or K2 changes. But depending on what you are trying to program for some reason, you might not want it to change until K1 and K2 changes. You might want it to hold off doing that. But that's going to depend on what this might be a larger part of. So I'll just have A, B, C, K1, K2, and you can either put commas in here or you can put the word or in between them. I'm going to do this, I'm going to do this a little bit differently just so you can see how it is. I'm going to, just for practice, I'm going to change this K1, K2 to K. And I will have input uh, 2:1 K. And now that's just like having K1 and K2. It's just instead I will call them what do this, how does Verilog do it, with parentheses? I've been using MATLAB so much lately. I'll get it back. Well, I'm going to avoid that problem right now by instead. Nope, they use square brackets. Okay. So, so it will refer to them as K1 and K2. Okay, so now I'm going to have a, in my always block, if it has more than one thing in it, I have to have a begin statement. I actually am only going to have one thing in here, but I'm going to put the begin statement in for right now because I might not know that when I start. And oh, the case statement doesn't actually work here. Yes, yes it does. Yes it does. Yes it does. Because I'm only depending on K. And so this is going to be K. So I'll begin. And now it's going to depend, F depends on what K is. And so I'll have a case statement. And my case statement will be on K. And then I have 4 different things that K could be. So K could be, K is a binary number. So K, now notice I put K2 in front and then K1. And this would be I think that would be, even though it has it as 1, 2 up here, probably the order of the multiplexer is probably, let me see. You'd have to look at the data sheet for the actual multiplexer to find out for sure. Let's see how your book does it. Does anyone know where multiplexers are? Oh, there's one. There's one. Zero, 1, 2, 3. S 1, 0. Yes, they have the most significant bit first. Yep, okay. Okay, so the multiplexer example in your book has the most significant bit first, so that means it would be that the first bit here, so this is, we have 0, 0, 0, 1, 1, 0, 1, 1. This one is K2 and this one is K1. And so on my case statement, I'm going to have, it's going to be the binary number. So to say that it's a binary number, I use the letter B, and to say that it's 2 bits wide, I do 2 apostrophe B 0 0. So that means if K is 0 0, so that means if K1 is 0 and K2 is 0, then I'll have begin, and I will have F. Now I don't need to begin because I just have one thing. I'll have F equals A, the not of A and B. Now, if K is 1, F equals let's go ahead and say it.
B or not C. To put the not C, I think you need to put that explanation on it.
Nope, Verilog uses the tilde.
Okay.
Yep. I don't think the exclamation mark works for Verilog. I don't think it does. It might though. And if it's 1 0, and by the way, you will sometimes see multiplexers rather than 0 0 1 1 0 1 1. You'll see 0 1 2 3 4.
In your drawing, you put like the K1 and K2 at the top, but at the bottom, the K2 and the K1. Is that?
It's not a typo. That's why that was all the time that I was going back and forth to the book to see which way the book did it.
Okay.
And so the book has it that so even though, okay, so if we look here, it has S is their select, and it has 1:0. So that means the most significant bit is bit 1 and then 0. So that means that S1 comes first and S0 comes second. And how their multiplexer looks, I don't know. Let's see. But that's what I was saying, is you would need to look at your data sheet for your multiplexer to see how it was set up. See, it does not really show me on the multiplexer. So this one has 1 in front and then 2. On the multiplexer has 1 in front and then 2. But then when we go and look at the code, well, I think that's the code I was looking at before. Anyway, that's why I did it in that order. So if you are uncertain, well, it's too late. Your homework is due tonight.
Tomorrow. Thank
Tomorrow.
God.
hold on just a second, let me see.
And then we could
What-
also like go to the old homework.
Yeah, that's what I was just about to do and see. But I know how to be in the old homework because it's from Dr. Trahan, and Dr. Trahan always does most significant bit first. I mean, it's frustrating for me because he does it that way, and but not everybody does. So if you look at the old homework, the way this is done, it has the case statement rather than having V defined as a separate variable. It has the inputs as V1 and V0, and then it puts them into curly brackets. And what the curly brackets does is it makes a binary number out of them, and it's putting V1 first and V0 second. And so it's doing that. It's making V1 the most significant bit. And if you look at the multiplexer, it has S1 on the left and S0 on the right. And is that the opposite of our multiplexer?
No, it's the same.
Yep.
That is an excellent question, and I'm so glad you asked because I made a mistake. Because I need to have output.
Is it because it's like an output of a multiplexer, not just a regular circuit?
Nope. It's because I am assigning its value inside an always block. When you assign it inside an always block, you have to make it a reg. And that means you can't assign it outside the always block. The reason why is because then Verilog says, well, wait a minute, you're calling it one thing here and another thing here. How do I know which one it is? That's a conflict. And so if you make it reg, you have to assign it inside the always block. I can't then say outside the always block, well, wait a minute, but if the enable, don't do this at all. You got to take care of all that inside the always block.
So you can output another output F? Because like maybe you don't want to just mess with F inside the always block. Maybe
No, you can't do that. Then you could have another variable. You could have a G. You could have an output G. But no, and sometimes it does come. You have to think about this when you're doing your coding, because it does come into play, and I have had to deal with that myself. Like, well, I really want to do this another way, and you can't. So you just have to keep that in mind. Okay, and then I think the rest of this is pretty obvious where you would go from here. So, yeah, any other questions on this? All right. Those were all very good questions. I'm so glad you asked about the reg.
Trust me, I've seen it first semester and I didn't bother to ask, which bite me back. For the now for the always add, would you say it's most likely going to be used only whenever we're doing things depending on the clock, or like do you think do we need it in regular cases like these?
I use it for multiplexers, but it is often going to be with the clock, and most of what you're going to be doing the rest of the semester is going to be with the clock. So you will see, like, let me just pull up some things from my previous semester.
And what does it mean to say always A, B, C, K? Because it doesn't say anything specifically going on with those.
It says if any of those change.
Oh, okay. I see what you mean.
It's Xilinx. And and this always takes a while to open. Okay, so any other questions?
That too. Is it because there's two Ks?
No, well, kind of. It's because K is a binary number, and it has 2 digits. So if I had a 8, pretend that's a trapezoid, I'm really going to have to fix this. Let's say I had an 8-to-1 multiplexer.
Maybe 0, 0, 0, 0, 0, 1. Okay.
It would be 3B000, 3B001. Now, I have on occasion just used the decimal numbers, 120, 1, 2, 3, and sometimes that works, but I have had times when it doesn't work, and so I just, to be safe, I use the binary numbers. So if we are looking at
Yeah, that's it.
project, so something like this is the final project, so it's likely to be a bit overwhelming when you see it. Y'all will not have the same final project. Apparently my final project had no, oh, there it is. Okay, so you'll see that I have like an always block here, and I have an always block with some variables changing. And then I have another always block with some variables. And I do most of my computation there. And then I have another always block that's always at positive edge of the clock. And that's where the thing actually happens. So it's like you have your other always blocks where things are changing, and then you're gonna have always at the positive edge of the clock. And that's usually gonna be a small bit. You're just gonna say, at the positive edge of the clock, do all this stuff that I did earlier in the program.
Now, always after, okay,